Hello everyone, in this video we are going to see question number 5 and 6 from exercise set 8.3 of class 9 CBSE chapter 8. Let's see. A ball is dropped from a height of 80 meters and after hitting the ground it bounces back to 60% of the height from which it fell. It continues bouncing in this way, each time rising to 60% of the previous height. So this is what the problem, and here we have two questions. One is we are going to find the height, that what is the height the ball reaches after the fifth bounce, and what is the total vertical distance the ball has traveled by the time it hits the ground for the sixth time. Okay, so before coming to the question, first we need to define the problem. So what was the problem exactly? So first we'll take one horizontal surface, and from 80 meter a ball has been dropped. So from this position a ball has been dropped, so the height is 80 meter. Now after hitting the ground, so the ball is going to bounce back again. So when it is bouncing back, obviously the height will decrease compared to the previous one. So how much it is bouncing back now? It is 60% of the previous height, that is 80 over here in this case. So how can I write this one? 60% we can write it as 0.6 of its in multiplication into 80. So what is the answer over here? 48 meters. So when it bounces back for the first time, it reaches the height of 48 meter. So again it is going to fall down, right? Due to gravity the ball will fall down. After it reaches 48 meter, it is going to fall down over here. So this period is bouncing for the first time actually. Okay, so at this stage we just drop the ball. When the bouncing will start? At this stage. So the bouncing started and it reaches the height of 48 meter, and again it faced the ground, it hit the ground. Now again after hitting the ground it's going to bounce back again. So now the bouncing back is going to be 60% of the previous height. So what was the previous height as of now, which is 48 meter? So now it's going to be 60% of 48, or even we can write it as 0.6 into 48. So if you multiply, we will be getting 28.8 meter. So for the during the second bounce, the ball reaching the maximum height of 28.8 meter. So now from this place again the ball after reaching 28.8 meter, it is going to come back and hit the ground once again. So this phase is during the bouncing of the ball for the second time. So after it hits the ground, again it is going to bounce back, and it reaches the 60% of the previous height, which is 28.8 meter, and again it is going to come and hit the ground. Like this process is going to get continue. Okay, so now we will come for the question. The question asked was, what was the question? What height does the ball reach after the fifth bounce? So like this is bounce 3, right? Like this is bounce 4 I can make, and bounce 5 is going to be even smaller. Okay, so this is bounce 5. So what will be the height during the bouncing for the fifth time? This is what our question. Okay, so now before doing that question, just we will define the terms. Okay, so what is T1? So the first time the ball dropped, there is no bouncing over there, for just it is a dropping of a ball. So the height is 80. So I am making my first term as 80. Now the second term. So what is the second term over here? So bouncing for the first time, right? So what is actually happening now? The height is going to become 0.6 into 80. Now, so this one I am mentioning as T1, and this place I will change a color. So this is T1, and this is T2, and this is T3, T4, T5, T6. So this is how I'm making. So now coming back, what about the T3? T3 is equal to what? 0.6 of previous side. So what is the previous side? It is 0.6 into 80. So how can I write this one? 80 into 0.6 to the power 2. Can I write? Yes, na? So we are trying to make a general equation. So it will be very easy to solve the problem. So now when we are coming for T4, so what is T4? Bouncing for the third time. So what is that? 0.6 into the previous height. What is the previous height? It is 80 into 0.6 the whole square. So now how can I write this? 80 into 0.6 the whole power 3. Here power 1 is there, here 2 is there, so we can make it as whole power 3. So from this what we are defining, we can define a general equation, right? So Tn is equal to 80 into 0.6 to the power n minus 1. So I am making a general equation. So now it will be very easy. If they ask it is bouncing for how many times, I can easily express it. Now we will come for the first question. What height does the ball reach after the fifth bounce? So this is bounce 5. Bounce 5 means what is the term? It is T6. So now we need to find what T6. That is what we are doing now. So T6 is equal to 80 into 0.6 to the power n minus 1. So it's going to be 0.6 to the power 5. So now if we calculate this value, we will be getting the answer for our first question. So for this the answer is 80 into 0 0.6 the whole power 5, we will be getting 0.07776. Okay. So again after we are multiplying this, we will be getting 6.2208. So now what height does the ball reach after the fifth bounce? It is going to reach the height of 6.2208 meter. This is also very important. And the second question is, what distance traveled by the ball till it hits the ground for the sixth time? So for the first time, it is actually hitting the ground of 80 meter. Okay, so I'm writing 80 meter. So again, how the ball is moving in vertically upwards, it is moving, right? Over here, see, it is going to bounce back. So it's nothing but there is also travel of vertical distance only. So what is this? It's going to be 48 meter. But after going 148 meter, again it is coming back for 48 meters. So I can write this as 2 into 48 meter. During the first bounce, it is going 48 and again coming back 48. So 2 times it is traveling vertically. That is why I am writing 2 into 48 plus. What about the third time, that is during the second bounce? It is 28.8 meter, right? So 2 times it is going to travel for the distance of 28.8 meter. So like that we are going to do till the fifth bounce. Okay. During the fifth bounce only the ball is coming back and hit the ground for the sixth time. So till that we need to make it. So the next one is plus during the next bounce it is going to reach the height of 17.28 plus during the next bounce it is going to reach the height of 10.368 and plus this one we already calculated. Now what is the height during the bounce 5? That is what the next term. So the next during the bounce 5 it is going to travel and hit the ground with the height of 6.2208. So now we are going to calculate all these things and we'll get the answer. So over here we can keep the 80 just as such, and for the remaining all the terms we have 2 common, right? So 2 I can take it outside, then we can add remaining all 48 plus 28.8 plus 17.28 plus 10.368 plus 6.2208. So it will be easy calculation, it will be. So I'm just adding all those things, and if I add we will be getting 110.6688. Okay, so then we are going to multiply 80 plus 2 and this we are going to multiply. So if you multiply we will be getting 221, that means 221.3376. So after adding we will be getting 301.3376. This much distance the ball traveled till it is going to hit the ground for the sixth time. So this is the answer for our second question. We'll see the next question now. So what is our next question? Which term of the sequence 2 comma 2 root 2 comma 4 is 128? They did not define you whether this sequence is an arithmetic progression or a geometric progression. Since it is given under geometric progression exercise, it is geometric progression, you may know. But the same question is asked in the exam. We need to first find whether this is an AP or GP. Then only we can substitute the formula according to it. So can we find first whether this is an AP or GP? So first for checking of AP, so what we are going to do? Second term minus first term. So first term is 2. So this is what our difference we are getting for the first two terms. And we will take any two consecutive term. We need to have a common difference. So I'm going to take the second term and third term. So third term minus second term. So I'll be getting this. 4 minus 2 root 2. So these two are not equal. So sure this is not an AP. So now we are going to check for GP. So how to check for GP? If they have a common ratio, then I can say it is a GP. So now I'm checking second term by first term. So I'll be getting root 2. Okay. So the same root 2 I need to get when I'm checking the common ratio for second and third term. So third term is 4 and the second term is going to be 2 root 2. So what we will be getting, 2 and 4 will get cancelled. 2 by root 2 will get, but we need to do the rationalization. Root cannot be in the denominator. So just we are doing the rationalization. So we will be getting 2 root 2 by 2. So 2 and 2 will get cancelled. Yeah, we are getting the ratio as root 2 again. So they are having the common ratio root 2. So this is a GP. So now we are going to define the given sequence is a GP, and over there which sequence, which term of the sequence will be 128. That means Tn is equal to 128. Then this n belongs to what term? So this 128 may be 10th term or 15th term, like that. This is the question. So what we need to find, n equal to what we are going to find. Okay, so before that what we required, the value of a and value of r. So what is the value of a? Value of a is the first term 2. And what about value of r? It's nothing but root 2 as per this question, right? So now we'll take the GP formula and then we will substitute the Tn value. We'll get the answer for n. So what is Tn formula? That means nth term formula in GP. So Tn is equal to ar to the power n minus 1. So for us, we know the value of Tn as 128. The only thing what we need to do, we have to find the n value. So now we'll proceed with the problem. Instead of Tn, we can replace ar to the power n minus 1, which is 128. And what is the value of a? It is 2. What is the value of r? It's going to be root 2 to the power n minus 1, which is equal to 128. So now I can move this 2 to the other side. So what is going to happen? It will become a denominator, right? So root 2 the whole power n minus 1 is equal to 128 by 2. So what is 128 by 2? It's nothing but 64. So now can I write this 64 in terms of 2 to the power? So how many 2 power what? It will be 64. 2 power 6 is going to be 64. Okay, so as of now, I got root 2 to the power n minus 1, and on my RHS, it is 2 to the power 6. So I am going to check. I just want to make that the base needs to be equal. Then I can easily equate the power. So we will get the value of n. But here the base is root 2, but on the RHS we have the base as 2. So is it possible to convert 2 to root 2? Yes, right. So I will give you first that idea. How can I write 2 in terms of root 2? So 2 is equal to root 2 the whole square. Can I write like this? So the same thing I'm going to follow over here. So keep the LHS as such. And now in my RHS, I'm going to write this 2 as root 2 the whole square. So both are having the same value. Why I'm changing this to root 2? So that on both the side we will have a same base. Then we can cancel the base and equate the power. That is the reason we have chosen like this. So and the 6 power will be there as such. Okay. So now what we can do? So power to the power calculation we have to do. So first we'll write the LHS root 2 to the power n minus 1 equal to root 2 to the power 2 into 6. So which is going to be 12. So now if you see this side also one term, this side also one term, both are having same base. So we can cancel the base and equate the powers. So what is the n value? It's nothing but 12 plus 1. So n value is going to be 13. So which term of the sequence is 128? The 13th term of the sequence is 128. Hope you understood. Thank you.